Here we are. This is Google Earth Engine, and the following demonstration is a flood event that occurred in Mozambique in 2019. And this exercise takes two Sentinel-1 radar images. These are C-band images, and they are from before and after the event. And we then create a ratio image of the two. A threshold is then applied to that ratio image to identify areas of flooding. And in this case, we are just identifying open water. And the threshold is set purely through trial and error by looking at the values of the areas that have high values in the ratio image. Also, in this case, we are using VH images to identify open water. So let's walk quickly here through the code. So up here is where you define your time frame, the time window before the event and the time window after the event. Your area of interest is, in this case, I drew the area of interest using the this polygon shape, but you can also upload a shapefile if you wish. So here are the parameters. We're using VH, we're using images from the descending path, and this is the threshold that we have set. And so the first part, you select there's a search for the Sentinel-1 images, and then the images are mosaic here and clipped to the study area, and a speckle filter is applied. Then we do the flood calculation. So we calculate the ratio. The Sentinel-1 images are in decibels, so they are logarithmic. And to calculate the ratio, you then subtract. And we then apply the threshold. Now, there can be some sources of confusion and error in the classification. So what we do then is clean that up. So we look at flooded pixels that are in permanent water bodies, and we bring in a layer of an ancillary layer that has permanent water. And so we remove the pixels that are over permanent water. We also eliminate the pixels that are connected to 8 or fewer neighbors. And we also remove the pixels that are the flooded pixels that are in slopes that are 5% or more. Then we calculate the flood extent and we convert that into hectares. And here in this part, we then bring in additional information to look at impacts. So we bring in a layer on population density, and we look at the flooded pixels that overlap with population density, and then we estimate the number of people that were affected by this flood event. Similarly, we do something for agriculture. We bring in a map that has an agriculture or cropland class from Podest, and then we look at the flooded pixels that overlap the cropland class, and we count the number of pixels, and then we convert that to hectares. Here we display the different products, and I'll show you what that looks like in a little bit. And here we have the exports. This is optional. If you want to export your results, you can export it as a TIFF file or as a shapefile. And then finally, this section below is to create the display on the map. So the results here, and then we have the legend over here. So let's take a look at some of the layers here. So first of all, this is our area of interest. And under layers, we can then take a look at the image, the Sentinel-1 image before the flood and the one after the flood. And we can look at the ratio image. And then this is our flooded classification. And this is the map of population density. And then this is the exposed population. You can zoom in. You can see that. And so here's the scale. And then cropland This is the cropland map, and this is the affected cropland. So that gives you an idea of how you can pull in ancillary data sets to really kind of understand what the impacts might be. In this case, on population, on land cover, but you can also bring in, like, so for example, an infrastructure roads type shapefile. You can use this code. It's in the presentation, in the PowerPoint presentation, and you can modify it to your area or event of interest.